Our next two videos, we're moving to a little bit more advanced topics. We're talking about creating bins and creating discrete groups. Let me move this out of here for the moment. To get our mind around what this is, imagine we have a group of ages, and here from 20, well, let's run this, 21, 22, 23. So we have a group of ages between 21 and 50. And let's imagine that we want to break these into separate groups. So you'd have 21 through 30, 31 through 40, and 41 through 50. You might have some reason for doing that. Right here we're imagining that, you know, these 20-year-olds, they like rock and roll, and 30-year-olds, you know, they like jazz, and 40-year-olds, they're going to like classical music maybe. Stick a 42 in here, and a 43. What we're doing down here is using this pd.cut method, and it takes two parameters. The first parameter is the data set that you're working with, and the second parameter is a cut definition. So we're saying create one group between 20 and 30, create another group between 30 and 40, and create a third group between 40 and 50. And we're naming this groups. So let's cut ages and output groups. We get some general information out of here that we have three groups, a 20 to 30, a 30 to 40, and a 40 to 50. It also tells us that 21 here is in the 20 to 30 group. 22 also is in the 20 to 30 group. And then it gives us our last one where 50 is in the 40 to 50 group, like that. Let's look at this codes method. Anything from 21 to 30, it's given a 0 code. Anyone from 31 to 40, it's given a 1 code. And every number from 41 to 50, it's given a 2 code. And these are integer types. Here's a categories attribute, which basically is this same information. But it's telling us that it's closed right. So it means that the right side is non-inclusive and the left side is inclusive. You'll see that in these brackets, which are standard computational set notation. Generally what that means is that we can put a 20 here and run this again, and it refuses to accept that 20 because that 20 is outside of the definitions that we gave here. It might not look like it, but we have to remember that this 20 is exclusive and the 30 is inclusive. So if we remove this again and run this, everything's back to normal. Now, this is another parameter that we can add here, labels, and that would go as a third argument. And if we run that, then now we've renamed these rock and jazz and classical. So we've renamed our categories. So running these is still the same. The codes will still be the same, but the categories have changed. And if we run these groups, then it says there's 10 that like classical, 10 that like jazz, and 10 that like rock. Let's knock off a couple of these values, knock out 3 of them, run this again, and then run our value counts again. And now we only have 7 who like rock. Have to run that again. We only have 9 that like jazz. This is an example of binning, or creating discrete groups, or discretizing our data. Here we're defining very specifically what our cut sizes are going to be. We can also simply stick a 4 in here and say we want it to cut 4 times. Let's create some random numbers, and then we're going to cut this into 4 sections. And these are our intervals from 0.27 all the way up to 0.81, and it's cut them evenly, saying that these are less than these, which are less than these, which are less than these. This precision equals 2 is simply saying that rather than having all of these decimal points, we only want 2 decimal points. So adding that attribute definitely shortens down our data. In these sections up here, we used the pd.cut method. There's another method that we can use here called qcut, and it does almost the same thing. To understand what's happening here, we need to think about quartiles. This Q basically stands for quartiles. So imagine that you had some numbers, maybe like that, and you maybe had 20, 30, and 90, and then I don't know, 150, and 200, and 600. Okay, what your quartiles is going to do, your middle number looks like it's going to be right here, maybe 15.5. That would be your median. And what quartiles are is they'll take your first quarter, your first 1/4 of your numbers is 1, 2, 3, and your second quarter is 6, 9, and 11. Your third quarter is these three numbers, and your fourth quarter is these three numbers. It cuts by quartiles, and in this case it will usually have more equal distribution of values in each bin. Okay, what we mean by that, if we look up here, we see that we have an unequal number of values in these bins. Let's come down here and create, like 1,000 values, and we'll Q-cut that into 4 bins. And if we run these counts, it tells us that there's 250 values in each bin. That's exactly 1,000. So let's go in here and put like 311. So that's a prime number, right? Run this again, and then run value counts again. There are 78 values here and only 77 in one of the bins. So it tries hard to evenly distribute all your values. And we're going to talk about where we use this. These might seem a little bit abstract to you now, but they're good for group operations, for group analysis, and also for statistical aggregation. And we're going to lean on them a little bit heavily later on.